The population of zebu cattle in a particular country is modelled by two subpopulations, adults and juveniles. In this model, the only factors affecting the population of the zebu are the birth and survival rates of the population. Data recorded in the years preceding 2018 was used to suggest the annual birth and survival rates, and the results are in the table below. So this table is showing that 23% of the adults are giving birth. It shows that 97% of the adults are surviving. It's showing that 0% of the juveniles are giving birth. And it's showing that 87% of the juveniles are surviving. We are then told that 1/3 of the surviving juvenile population grow up and become adults each year, which would mean that 2/3 of the surviving juvenile population don't become adults and therefore stay as juveniles. Let AN and JN be the respective subpopulations in millions of adults and juveniles n years after the 1st of January 2018. Then the adult population in year n+1 satisfies this equation. So this equation is showing that adults in the next year, hence why it's n+1, is equal to 0.97 times the adults of the previous year. That makes sense because we were told that 97% of the adults survive. So this part here is just saying that the adults the next year is equal to 97% of the adults from the previous year that survived, plus we've got 1/3 of the juveniles that survived have now become adults. So we know this is the juveniles from the previous year. Only 87% of them actually survived. And then of those that survived, 1/3 of them became adults. And then this has just been simplified. We've got the 0.97 AN, which is there. And the 1/3 times 0.87 is 0.29. So this equation is just saying the adults the next year is equal to 97% of the adults from the previous year plus 29% of the juveniles from the previous year that have now become adults. We need to form the corresponding equation for the juvenile population in the year n+1 under this model. So what I've done here is I've said the juvenile population in the next year is equal to 23% of the adult population that gave birth. So 23% of the adult population created a child, created a juvenile. So that's why we've got those new juveniles here that are being born. Plus we've got the juveniles that survived last year, so 87% of them. But remember that 1/3 of them became adults. So there's only 2/3 of them that are still juveniles. So 2/3 of 0.87, which is the 0.58. So 58% of the juveniles from the previous year are still juveniles. So that's my equation, and I've just explained how I would justify those values. I would write a sentence and say 23% of the adults give birth, so create new juveniles, and 2/3 of the surviving juvenile population remain juvenile. And that sentence would explain my equation, would justify the values. We are then told that the total population on the 1st of January 2018 was estimated to two significant figures as 1.5 million zebu, with 1.2 million of those being adults. So the difference between them, that means that 0.3 million of them must have been juvenile. Part B. Find the value of P and the matrix equation M such that the population of zebu can be modelled by the system. So A0, that's the population of adult zebu, 0 years after 2018. And we can see that that's 1.2 million because we were told there were 1.2 million adults at the beginning. Which means that P has to be 0.3 because that corresponds to the juveniles, 0 years after 2018. And we know there's 0.3 million of those because we were told that there was a total of 1.5 million at the beginning. Then I've set up my matrix equation. I've set it up here, look, where I've got the adults, the next year is equal to 0.97 times the adults from the previous year plus 0.29 times the juveniles from the previous year. That's that equation we were given. And then we've got the juveniles the next year is equal to 0.23 times the adults from the previous year plus 0.58 times the juveniles from the previous year. That's this equation here. Just set up much nicer. So that's my answer to part B. This is my matrix M. This is the value of P. Part C. Using the model formed in Part B, find 3 significant figures. Part I, the total zebu population that was present on the 1st of January 2017. So, have a look at this equation here. We've got the populations in 2018 are equal to our matrix times the populations in 2017. Now, we know what the populations were in 2018. We were told that in the question. We were told that the adult population was 1.2, the juvenile population was 1.3. So if I want to work out what the populations were the year before that, in 2017, I can multiply both sides of my matrix equation by the inverse of my matrix M. So that calculation, the inverse matrix of 0.97, 0.29, 0.23 and 0.58 multiplied by the matrix 1.20.3 gives, on my calculator, 1.228 and 0.0302. So this is the adult population there were in 2017. This is the juvenile population there was in 2017. So the total population then, I'm going to add those two numbers together, and the total population then is 1.26 million. And that is my answer to part I of C. Part II says to find the predicted juvenile population on the 1st of January 2025. So I know that I can find the population in 2019 by taking my matrix and multiplying what it was in 2018, which we know what that was. We were told that in the question. We know that the adult population in 2018 was 1.2. The juvenile population in 2018 was 0.3. So that calculation would tell me what it is in 2019. But we don't want it in 2019, we want it in 2025. But if I took my result from 2019 and multiplied that by the matrix again, that would tell me what it would be in 2020. Or quicker, rather than doing it in two goes, I could just multiply the 2018 values by my matrix squared. Because multiplying once would give me the 2019 values, multiplying twice will give me the 2020 values. Similarly, if I wanted it in 2021, I could just take my original 2018 matrix and multiply it by my matrix M cubed. 2022, multiply again to be power 4. 2023, multiply one more time to get the power 5 now. 2024, multiply it by power 6. And then finally, to get it one more time, to get it into the year that we want, to find out the values in 2025, we are taking our matrix M, putting it to the power 7 before multiplying it by our 2018 values, and we find that the adult population is 2.117 million and the juvenile population is 0.938 million. So the predicted juvenile population then was 938,000. That's my answer to part CII of this question. Then finally, as a result of the predictions of this model, the country will export 15,000 juveniles to a neighbouring country at the end of each year. We need to adapt our model accordingly. So remember, let me just rewrite my model down. The model is usually a n plus 1, j n plus 1 is equal to the matrix there times a n j n. And we need to adapt this model for the fact that we are exporting 15,000 juveniles every year. So we're taking 15,000 juveniles away each year. So just giving myself a little bit of space so that I'm able to subtract those 15,000. The adult population is not affected at all, so we would subtract 0 from the adult population. The juvenile population, we're subtracting 15,000, which in terms of, remember, these values are in millions, so 15,000 in millions would be 0.015. So what I'm saying here then is the adult population the next year is 0.97 times the adult population from the previous year plus 0.29 times the juvenile population from the previous year, take away 0. But crucially, what I've adapted here is I'm now saying that the juvenile population the next year is the 23% of adults that gave birth plus the 0.58, the 58% of juveniles that remained as surviving juveniles, take away the 15,000 that have been exported to the nearby country. So I've adapted the equation. I do need to put in the starting values though, because they are part of my model. So I do need to say that A1 or A 2018 is 1.2 and juveniles at the beginning is 0.3. So this is my new model, considering the fact that we are exporting 15,000 juveniles to a neighbouring country every year. And then finally, part E, we need to state one limitation of this model. So lots of different things we could criticise here, or certainly lots of limits here. We could say that there are unlikely just to be adults and juveniles. There's going to be more subpopulations within the population of zebu. There's probably going to be some elderly zebus that might not be able to give birth at the same rate as the rest of the adults. So that's one limitation of the model, just saying it's unlikely to there only to be two subpopulations. We could say that the birth rates and the death rates are going to fluctuate. They're going to change each year. They're not going to be stuck at the 97% and the 23%. So I think those are probably we could also say that exporting the 15,000 juveniles each year, that's going to have an impact on birth rates and survival rates probably as well. So there's a few different things we could say that are limitations of this model.